I'm pretty confident in saying that this is a very popular unit on the Regents exam. So you can expect to see somewhere around like 7 to 8 questions from this unit. So please make sure that you are well familiar with all the concepts. So here are the first few questions. So these questions are kind of about the atomic theories. So please make sure that you are familiar with the atomic theories, especially the Rutherford theory, the wave mechanical. So you should know what the orbital means. You should know who discovered the electrons, and then you should know what Bohr said. Dalton is not that common, but the rest of them are something that you should be familiar with. So the first question is saying what conclusion was proposed as a result of an experiment during which some alpha particles were deflected while passing through a thin sheet of gold foil. So this was Rutherford's experiment, and if we remember, Rutherford bombarded the alpha particles on a thin sheet of gold foil. Some of them went straight, some of them deflected in different directions, and some of them bounced back. So Rutherford said that the reason why some of them were going in different directions or bouncing back is because there was something positively charged in the middle of the atom that was repelling those particles, which is why they were coming back. So Rutherford was the one that discovered that positively charged nucleus, and then Rutherford also said that in general, because a lot of the particles were able to go pass straight through, that was because there's a lot of empty space between in the atom, which is why there was nothing that the particles were interacting with. So it was just empty space. Particles were able to go straight through, and Rutherford was able to record them on the other side of the sheet. So the conclusion here was that atoms have small, dense positive nucleus. That was one part of Rutherford's experiment and his conclusion. And the second part was that atom is mostly empty space. So remember the ESPN. This was Rutherford's conclusion. So that means atom is mostly empty space and it has a positive nucleus. Then for number 2, we are talking about the wave mechanical model. So in the ground state, the 10 electrons of a neon atom would be located. You should know that wave mechanical model was the one that said that electrons are actually in the orbitals, which are spaces where we have a very high probability of finding an electron. But electrons are not specifically in like specific circular orbits that were mentioned by Bohr. For number 3, which proposal is in the development of the modern model of the atom was made before the others? So we are talking about the one that was discovered we are talking about the one that was proposed at the very beginning. So the first option is atoms are hard indivisible spheres of the different sizes. Atoms are mostly empty space. We just said that this one was Rutherford, so that was not the first one. Atoms have electrons that have wave-like properties. This one was the cathode ray tube experiment by Thomson, so that was also not the first one. And then atoms have an internal structure that contains negative particles, which is kind of like what Thomson said somewhat, so also not our answer. So the first one was this, which was presented by John Dalton. Then for number 4, which subatomic particles were discovered as a result of experiments with cathode ray tubes. So this experiment was done by J.J. Thomson, and after the cathode ray tubes, the subatomic particles that was discovered was the electrons. Here are a few more questions. For number 5, which particles surround the nucleus of a neon atom? So remember, outside the nucleus, we always have the electrons, whether it's not just specific to a neon atom, for all the atoms. For number 6, which subatomic particles are matched with their charges? So we have protons that are positively charged, we have electrons that are negatively charged, and we have neutrons that have no charge. So positive nucleus, negative electron, neutron with no charge. So the correct answer that we see here is number 2. Then we have number 7, which says what is the overall charge on the nucleus of a fluorine atom. So you just have to figure out how many positive charges do we have in the nucleus of a fluorine atom. So remember, the charge on the nucleus is always positive because inside the nucleus we have a proton and a neutron. Protons are positive, neutrons have no charge. So the charge of the nucleus depends on the number of protons only. So figure out how many protons you have in fluorine, which I believe is 9. So that will be positive 9. What is the net charge of a monoatomic ion that has 15 protons, 16 neutrons, and 18 electrons? Now remember, when we are talking about the net charge, that means we are talking about the charge on the atom. And that depends on the number of protons and the number of electrons. Number of neutrons do not matter because they have a charge of 0. So in this case, what we are saying is that we have 15 positive charges and we have 18 negative charges. So overall, as you can see, we have more negative charge. So you just have to calculate that difference. So because it's 3 more negative charges, so the overall charge is going to be -3. The mass of each proton and each neutron is approximately equal to. This is a very important concept to remember. When we are saying approximately equal to, we are only talking about the relative number. So if we are saying that the mass of a proton is about 1 atomic mass unit, which is this symbol, this means atomic mass unit, then the mass of a neutron is also about 1 atomic mass unit. What we are trying to say here is that the proton and the neutron pretty much weigh the same. The electrons are significantly lighter to a point where their mass is negligible. But remember, we do not want to say that electrons have a mass of 0 because they do exist. If something has a mass of 0, that means the thing doesn't exist. So protons and neutrons weigh the same. Electrons are significantly lighter, which is why for atomic mass, we only count the mass of the proton and the neutron. So what is the approximate mass of an atom that has 10 electrons, 10 protons, and 9 neutrons? So remember, we do not need to consider the mass of the electrons. So we can only consider the mass of the protons and the neutrons. So that will be approximately 19. Here are a few more questions from Atomic Concepts. For number 11, all atoms of an element have the same atomic number or number of protons. So number of protons determine the identity of that atom. This concept should be on your fingertips. What's the number of protons in an atom with the electron configuration 2, 5? So quick reminder on electron configuration, this means we have 2 electrons in orbit number 1 and 5 electrons in orbit number 2. So there are 2 orbits in this atom. So overall, we have 7 electrons. And for a neutral atom, an atom that has a charge of 0, the number of electrons is equal to, number of electrons is equal to the number of protons. Once again, this only applies to a neutral atom, the one that does not have a charge. And I spelled neutral wrong. Right, neutral. Right, amazing. So that means if you have 7 electrons, we should have 7 protons. So in a ground state, valence electrons of a krypton atom are found in. So your valence electrons are defined as the electrons in the outermost shell. So this is just a definition problem. Which atom has a mass of 12 atomic mass units? So we are looking for something where when we add the number of protons and neutrons, we get 12. So for A, when you add protons and neutrons, you get 8. For E, when you add protons and neutrons, you get 12. For G, when you add 6 and 7, you get about 13. And then for J, you get about 24. So your answer to this question will be E. Because once again, remember, mass is the number of protons plus the number of neutrons. For number 15, in all atoms of bismuth, the number of electrons must equal the number of protons, as we just said. And because this is saying an atom of bismuth, we are just going to assume that this is a neutral atom, because if it had a charge, the question would have said all ions of bismuth. So if it says atoms, we can assume, safe to assume, that this is a neutral atom. What's the net charge of a monoatomic ion? Now here we are talking about an ion that has 15 protons, 16 neutrons, and 18 electrons. This question is similar to the one that we did before. I think it's the same question. So that should be 3 minus, because we have 3 more electrons. Then we have number 17, which particle remains undeflected when passing through this electric field. So remember, in chemistry, opposite charges attract. So the things that are negatively charged are going to be attracted towards the positive side. The things that are positively charged are going to be attracted to the negative side. So the only thing that is going to be able to pass straight through is the one that has no charge. So that will be your neutron. Then we have some short response questions. So explain in terms of subatomic particles why atoms of hydrogen 1, hydrogen 2, hydrogen 3 are each electrically neutral. When we are saying something is, or an atom is electrically neutral, that means the number of protons is equal to the number of neutrons. Now, someone might say, but how do we know, sorry, apologies, not neutrons, electrons. Neutrons do not impact the charge. So someone might say that, well, how do we know that the number of protons are equal in all 3 of them when we see a different number written next to hydrogen? Because remember that this number that is written with the symbol of the element is the mass number. And mass number is the number of protons plus the number of neutrons. Mass number has nothing to do with electrons. And when we see the same element written with 3 different numbers, we know for sure that the number of protons is not changing in all of them. And we know that because it's still the same element. So as long as it's the same element, it's going to have same number of protons. So the only thing that's changing here is the number of neutrons. So if the number of protons is the same, that means number of electrons is also going to be the same. So to answer this question, you can simply say this part. So you can say these 3 atoms are electrically neutral because the number of protons is equal to the number of electrons. So state the number of valence electrons in an atom of sulfur 32 in the ground state. Just look at the electron configuration of sulfur. Look at how many electrons you have in the outermost shell. That's your answer. Determine the number of neutrons in an atom of Am241. So this is going to be calculating the number of neutrons, which I hope we all still remember is going to be the mass number minus the atomic number. So the reason why we are doing that is because, remember, our mass number is protons and neutrons. So when we go ahead and subtract the number of protons from that, we are left with the number of neutrons only. Then 21 is state the number of electrons in an atom of lithium 7. So go to lithium, its electron configuration. You can add the number of electrons, or you can simply look at the number of protons for lithium, the atomic number, and that will be your answer. And then state in terms of neutrons why a water molecule containing oxygen 18 atom has a greater mass than a water molecule containing oxygen 16 atoms. So the question says in terms of neutrons. So to answer this question, you can just say oxygen 18 has more neutrons. So once again, these are 2 different forms of oxygen. So they have same number of protons. So the only thing that's different will be the number of neutrons. Or you can also say the oxygen 18 has 2 more neutrons. That is also totally fine. Right, a few more questions. Which electron configuration represents the electrons of an atom in an excited state? So remember, excited state is a very temporary state. This is when you provide energy to an atom and the electrons get excited. So they move to a higher energy level because now they have more energy. But it's very temporary because very quickly the electrons come back to their original state, which is called the ground state. And as they are coming back, they release some energy that they had absorbed initially. So we are, to answer this question, we are looking for an option where we have an unfilled orbit, but we still have electrons in the next orbit. So if you look at option 1, you can see that orbit number 1 is complete. Orbit number 2 is incomplete because it can actually fit 8 electrons, but we only see 7 in this case. So what this tells us is that 1 electron from the second orbit has moved to the third orbit. So this could be an excited state. If you look at option 2, we see that orbit number 1 is complete, orbit number 2 is complete. So in this case, nothing is incomplete. So this is just the ground state. If you look at option 3, we have 2, 8, 8, 1. So 1 looks complete, 2 looks complete, 3 looks somewhat complete. So this is also a ground state. And then in case of 4, 2 is complete, 8 is complete, and we do have some ground states because orbit number 3 can essentially have 18 electrons, but after we fill in 8 electrons, 2 electrons go to the start filling orbit number 4, and then they come back to fill orbit number 3 completely, because that's how energies work. For you guys who have where we have not talked about the specific energies or how the orbits are filled, you can simply just look at the periodic table and see if there is an element that has this oxidation state written, because if there is an element with this ground state oxidation state, then this just represents a ground state. Same thing for the previous one. So your answer in this case will be 1. So compare the energy of an electron in the first shell of a lithium atom to the energy of an electron in the second shell of the atom. So one question that you should absolutely not get wrong. Remember that the energy of the orbits increase as we go away from the nucleus. So electrons need to have more energy to occupy the orbits that are farther from the nucleus. So you'll simply just say that the second shell has more energy than first. Then identify the noble gas that has atoms in the ground state with the same electron configuration as the nitrogen atom in a molecule of ammonia. Now this is interesting. If you remember, we said that ammonia is NH3. Now, if you draw this out, nitrogen has 5 valence electrons. So 1, 2, 3, 4, 5. And these 3 electrons that are not in a pair, they are going to make a bond with hydrogen. So overall, if we have to count the electrons that nitrogen has, because it has 5 of its own, and then it's also sharing 3 electrons with hydrogen. So nitrogen actually has 8 electrons in this case. So we are looking for a noble gas that has 8 electrons. So go to the periodic table and find the noble gas that has 8 electrons. Then we have a few more questions. So which change in electron location in an atom of calcium is accompanied by the greatest amount of energy emitted? So when we are going from shell 1 to shell 2, because we are going from low energy to high energy in this case, so energy is actually going to be absorbed instead of being emitted. So this is not your answer. When we go from shell 2 to shell 1, now energy is going to be emitted. So this could be a possible option. Then as we go from 1 to 4, in this case, once again, we are going from low to high. So energy is going to be absorbed instead of emitted. But when we go from 4 to 1, this could be a possible answer. So, but the question is asking for the greatest amount that is emitted. So remember, if we are coming back from 4, which has significantly more energy compared to 2, so when we come back from 4 to 1, that is going to release more energy compared to when we are coming back from 2 to 1. As an atom in the ground state changes to an atom in an excited state, So remember, what we are saying here is that when it's in the ground state, it's in a low energy state, and then it's going to a high energy state. It needs to absorb the energy to be able to go to that high energy state. And then here we have two atoms. The question is saying what is represented by diagram 2. So what we see here is that electron was in orbit number 1, and then it moved to orbit number 3. So it looks like the electron got excited and it moved to a higher energy level. So we can say this, that an atom of hydrogen is in an excited state. We know for sure this is hydrogen, although this will be written in the question somewhere, but because in this case we don't see the entire question, so we know this is hydrogen because it only has one electron, and hydrogen only has one electron. And then this, I believe, these are the last questions. So which elements are present in the mixture? This is about bright line spectrum, and there are only two things that you need to know about bright line spectrum. The first is that you will be given a spectrum of different elements, and then you'll have a mixture, and your job will be to identify what elements do we have in the mixture. So all you have to do is match the lines. So if I look at the mixture now, I see that the first line comes from element E. The second line seems to come from element E as well, and there is also a line in J. The third line and the fourth line, that double line, is in element G. Then I see this line, which seems to come maybe from L, but also from E. And then I see the last one, which seems to come from E. So remember that although I see one line from element J and one line from element L, probably in our mixture, we will not say that we have J and L in our mixture, because all of the lines must be present in the spectrum of the mixture. So element E has all of its lines present, which is why we are sure that element E is present in the mixture. Element G also has all of the lines in the mixture, so we are certain that G is present. So your answer is E and G. And then the second type of question that you must be able to answer is, how is the bright line spectrum created? So remember how we were saying that when an electron absorbs energy, it goes to a higher energy level, and then when it's coming back and it releases that energy is what creates the bright line spectrum. So you can say that when you are answering this question, remember that the absorbing part is not creating the spectrum. So even if you are answering this question as a short response, make sure that you do not include this part. The absorbing has nothing to do with the creation of the spectrum. The only thing that you need to mention is that the electron comes back from an excited state to a ground state, or you can also say from a higher energy state to a lower energy state, and releases energy. So the correct option here will be D. It releases energy and moves to a lower energy state. And that was it for your, actually no, sorry, never mind. A few more questions. These are the last ones. So state in terms of both protons and neutrons, while UUS-293 and UUS-294 are isotopes of the same element. So we know they are the same element because they have same number of protons. So for your answer, you'll say they have same number of protons, and we know that they are different isotopes because they have a different mass, which means they have different number of neutrons. So for your answer, you'll just say these atoms have same number of protons, different number of neutrons. And then this is something that you must know how to do. And that is calculating the atomic mass, or average atomic mass. So this is not your regular average. This is actually the weighted average of the masses of all of the isotopes. So we take into account the mass and the percent abundance of all of the isotopes. So you have a few ways to answer this question. First way is, what is our correct answer in this case, which is option 4. So as you can see, what they did is that for copper 63, we multiplied the mass of copper with the with this percent, but after dividing the percentage by 100. So if we divide this by 100, we get 0.6915. If we divide this by 100, we get 0.3085. So we multiply these two, add them. So that is your average atomic mass. The second thing that you can do is, if you are writing it like this, the reason why 1 is incorrect is because if you're just writing your, sorry, not 1, 2. The reason why 2 is incorrect is because if you just go ahead and write your mass with the percentage, when you multiply them and add them, you end up with a huge number, which is very different from the atomic masses of the isotopes. So you must remember to divide your answer by 100 to make sure that you are accounting for that percent unit. And a third variation of this answer that had showed up very rarely, but sometimes on the Regents exam, is that they write it in this form, but instead of dividing it by 100, they just go ahead and write a percentage with the percent. So if you don't see either your answer dividing by 100 or you don't see your percentages multiplying after they have already divided by 100, then look for something like this where the percentage is written, because the percent sign technically indicates that we still need to get rid of this percentage before we get to the final answer. And then for number 33, which notations represent atoms that have the same number of protons but a different number of neutrons? So we are looking at some isotopes. So remember, isotopes represent the elements of the same element, the atoms of the same element, because they have same number of protons. So if you see different elements like hydrogen and helium, those are not isotopes. See sulfur and sulfur, although it's the same element but the mass is also the same, that means they are not isotopes. If you see chlorine and chlorine, same element, and they have different number of neutrons, so these could be isotopes. Then here you have Ge and Ge, they're like different elements, so not your answer. And then lastly, based on the atomic number of element nitrogen on the periodic table, compare the relative abundances of the naturally occurring isotopes of nitrogen. This is kind of a rare question, but you must know how to answer this. So if you look at your periodic table, let me pull up my periodic table very, very quickly. Okay, so if you look at your periodic table and you go ahead and look at the mass of nitrogen, we have about 14.00 something, so that can be rounded to a 14. So because that number is closer to the mass of 14, we can say that this isotope is more abundant. So to answer this question, you'll say that nitrogen 14 is more abundant because the atomic mass on the periodic table is closer to 14. So that was it for the atomic concepts. Moving on to the periodic table.